Hello everybody, this is Naveen S. Sapare, Assistant Professor, Department of Mathematics, KLIT Hubli. We will continue Fourier transform. So we solved a few problems in the previous videos. So today again we will solve some more problems. Hello everybody, this is Naveen Sapare, Assistant Professor, Department of Mathematics, KLIT Hubli. So today's class we take a Fourier transform and we solve some more problems on that. The problem says that find the inverse Fourier transform of e raised to minus u square. So in this problem we need to find the inverse Fourier transform of e raised to minus u square. It means that here Fourier transform of the function f of x is given and we need to find its inverse. Inverse means in this case we need to find out the function f of x since given is f of u. Solution: Fourier inverse transform is given as f of x equal to 1 by 2 pi integral minus infinity to plus infinity f of u into e raised to minus iux with respect to u. Since given the Fourier transform, that is f of u here. So f of u is e raised to minus u square. So when f of u is given, we need to find f of x, and here the inverse Fourier transform of e raised to minus u square means we need to find f of x. So substituting f of u, so we have 1 upon 2 pi integral minus infinity to plus infinity. F of u is nothing but e raised to minus u square into e raised to minus iux with respect to u. And when we see this integral, definitely this integral is not in the standard form to evaluate it. Therefore, what we need to do is we need to reduce this integral into the standard form of integral so that we can evaluate the integral by using the known methods. So our first work is to reduce this integral into the standard form so that we can evaluate it by using unknown formulas. So I will move to the next step to reduce this integral into the standard form. So it is minus infinity to plus infinity is a limit. So e raised to, I will take minus sign outside and it become u square plus iux with respect to u. And still the integral is not in the standard form. That's why I'm going to make some adjustments, adding, subtracting and all, some adjustments I'm going to do so that I can reduce it into the standard form. So it is e raised to minus of, I will keep this u square as it is, and this iux I will write it as 2 times of iux divided by 2. When I cancel this 2 and 2, definitely I will get again iux. Then I am going to add I square x square by 4 and subtracting I square x square by 4. Why I am subtracting and adding? Why I am making this adjustment? I just said that we need to reduce this integral into the standard form so that we can evaluate the integral. So simplifying further, so it is 1 upon 2 pi integral minus infinity to plus infinity e raised to minus, so here u square plus 2iux divided by 2 plus I square x square by 4, I will take them in a single term. It is single term, that is first exponential form, that is u square plus 2 times of iux divided by 2 plus I square x square by 4. I will take these three terms in the first bracket. Later I will take e raised to first these three terms. Next I will take one more exponential. Then I will take this last term with this exponential. So minus into minus become plus here. So it is I square x square by 4. So again when you multiply these two exponential functions, again you will get the previous steps answer only. So it is 1 by 2 pi integral minus infinity to plus infinity, again e raised to minus in bracket. Now we know that u square plus 2i ux by 2 plus I square x square by 4 can be written as u plus ix by 2 the whole square. If you simplify this u plus ix by 2 the whole square, applying the formula a plus b the whole square, definitely you are going to get this term only. And again this one I square is nothing but we know that it is minus, so minus 1, so it is e raised to minus x square by 4 will remain because I square value is minus 1 with respect to u here also as well as here also. Okay, next step. And since we need to evaluate this integral with respect to u, okay, we need to evaluate this integral with respect to u, and therefore we consider this e raised to minus x square by 4 as a constant. Therefore we have here f of x equal to e raised to minus x square by 4, I will take it out, divided by 2 pi. Why I am taking e raised to minus x by x square by 4 outside? Because this integral we need to evaluate it with respect to u, therefore x will be considered as a constant. Therefore we have integral minus infinity to plus infinity e raised to minus of u plus ix by 2 the whole square with respect to u. So now to evaluate this integral, I am going to take a substitution u plus ix by 2 is equal to t. Integrating with respect to u here, but here when we take a substitution we need to differentiate it with respect to t. So we have du is equal to dt and the limits will remain same, that is minus infinity to plus infinity only. Therefore the function f of x become e raised to minus x square by 4 divided by 2 pi, limits integration between minus infinity to plus infinity, e raised to minus t square with respect to t remains. This implies e raised to minus x square by 4 divided by 2 pi. And since we are having the value of this integral, by using the definitions which we studied in beta and gamma functions will be root of pi. So this is the required inverse Fourier transform, and hence that's the solution. Next problem, find the Fourier transform of e raised to minus of mod x. So finding a Fourier transform of the given function, that is here e raised to minus of mod x, means we need to find f of u. So again we use the same formulas, that is the Fourier transform of the function f of x is given as f of u is equal to minus infinity to plus infinity f of x into e raised to iu x with respect to x. And since the function given is e raised to minus of mod x, so given here it is f of x is equal to e raised to minus of mod x. Now we need to substitute this function f of x in this formula. So it becomes minus infinity to plus infinity e raised to minus of mod x into e raised to iux with respect to x. And since here the function f of x contain a mod of x, that is mod function, so whenever there is a mod function here, and since we know that mod of x will be minus x for the negative range and mod x will be plus x for the positive range, therefore we need to split this integral as a positive range as well as the negative range, because this integral contain both negative range as well as positive range. Therefore we will split the ranges as a negative range as well as positive range. So it is minus infinity to 0, it's a negative range. In the negative range this mod x will be minus x, so minus into minus become plus, so it become e raised to x into e raised to iux with respect to x, plus next we'll split it as 0 to infinity, which is a positive range, and in this positive range this mod x will be plus x, and since there is a minus sign, so it becomes e raised to minus x into e raised to iux with respect to x. Now we need to evaluate both the integrals separately. Therefore we will simplify it as minus infinity to plus infinity e raised to 1 plus iu into x with respect to x, plus it is integral 0 to infinity e raised to, I will take minus sign outside. Okay, so here taking minus sign, and inside the bracket it will be 1 minus iu and x outside with respect to x. So when you simplify this you will get minus x, and when you multiply with the minus iu you will get e raised to iux. Now evaluating both the integrals, and since we know that integration of e raised to ax will be e raised to ax by a, therefore this is obviously 0, so integration of this will be e raised to 1 plus iu x divided by 1 plus iu, and applying the limit minus infinity to 0 here, plus here also integration e raised to minus of 1 minus iu x divided by minus of 1 minus iu, applying the limits 0 to infinity. So now applying upper and lower limits, so obviously we know that upper limit is 0 and e raised to 0 will be 1. For this first term, applying the upper limit, e raised to 0 will be 1. So we have f of u is equal to e raised to 0 will be 1. So remaining is 1 divided by 1 plus iu. And coming to the lower limit, and since we know that while taking the lower limit we need to take a minus sign, minus of e raised to minus infinity, and since we know that e raised to minus infinity will be always 0, so second term vanishes here. And coming to this next term, upper limit is infinity, so e raised to minus infinity, again it becomes 0 because there is a minus sign here, and when you put x as infinity it becomes e raised to minus infinity, so e raised to minus infinity will be 0. Therefore for the upper limit the function become 0. Now coming to the lower limit, and since we know that while taking the lower limit we need to take a minus sign, so since there is a minus sign here, so minus into minus become plus sign, and e raised to 0 will be 1, and remaining is 1 divided by 1 minus iu. and that's the step after applying the limits. So now simplifying this by taking LCM and all. So taking a LCM, it becomes 1 plus IU into 1 minus IU. Just cross multiplying 1 minus IU plus 1 plus IU. So plus IU minus IU get cancelled, remaining is 2 divided by, and in the denominator a plus b into a minus b become 1 minus I square u square. And since we know that I square is nothing but minus 1, so minus into minus become plus. So we have 2 divided by 1 plus u square, and hence this is the Fourier transform of the function e raised to minus of mod of x, and hence the solution.